Welcome to this lesson on the application of a geographical information system. GIS is considered a horizontal technology. It's considered horizontal technology because it has a wide area of application in different sectors of the industry and the academic landscape. It has been said that the 80% of all the information that is produced are related to space. That's why it is difficult to have a list of the application. I shared with you an address that they selected 100 application of geographical information system. For the sake of this lesson, I borrowed the consideration of the Cranfield University. They organized the application of GIS in 6 M's, which is mapping, measurement, monitoring, modeling, management, and manipulation. So we can group all the application in this area. When we got the first M, which is mapping, GIS is used to produce maps and sometimes beautiful maps. I hope this one is beautiful. But GIS, you can produce beautiful maps presenting or communicating your information on the map. Unfortunately, many people stop here on the use of GIS. They just use to produce maps. But this is the first M, is the basic application of geographical information system, is to produce a map. With a GIS, we can do a measurement. We can measure distance, area, length, width. So I don't need to take a car and travel to one area to know the distance from one area to one place to another place. So I can do this calculation in GIS. But we can do some advanced measurements. This is Mozambique. This map presents the drought. In red areas are area of the problem of drought, and the blue area without drought. Because GIS use overlay information, I can use the settlement data belonging to the Mozambique and overlay inside this map. So what will happen? Each settlement will fall in the level of drought. And because the settlement has a population, I can do some summarize and have how many people are in each level of drought. So in this case, in this situation, I can estimate the number of people that are in danger of drought that will need humanitarian assistance. Another M is monitoring. Monitoring is to follow what is happening along the time or space. For example, these are vegetation condition images we call NDVI. We deal this more deep in a remote sensing course. This tell how is the condition of the vegetation in different areas. These are images of the last 10 days of January for 2019, 2020, 2021, and 2022. So we can see in Southern Africa how was the vegetation condition during this period. The more greener the area, the more healthy the vegetation. And less greener, less healthy is the vegetation. So we can see in 2020 in Southern Africa that we had the problem in all this area here. The vegetation seemed not good. Similar a little bit in 2019. But when you go to 2022, you can see this we call Horn of Africa, Somalia, Kenya, and even north of Tanzania. All Tanzania has the vegetation is not good. So it's different from this one image. You can see. So this is a monitoring. We can do monitoring in GIS. With this kind of image, you can even select a small area. It's not the scope of this course, of this presentation, to explain how this image was produced. But what we see, they present the drought. So I first the 4 decade in where we expect the vegetation to be in very healthy condition. So we have the last 10 days of December, all January for 2020, 2021, and 2022. Again, green, good condition, red, bad condition. So we can see that we expected to have drought in 2020. 2021, everything was good. 2022, everything was good, but we have some spot where we didn't expect a good vegetation condition. And in the area where they use rain-fed agriculture that depends on rainfall, if the vegetation is not good, we expect famine, hungry people will not produce food. Another M is modeling. So with modeling, we combine different spatial layer to produce a new information. For this erosion hazard map, the factor of erosion include the slopes or elevation, soil, land use, land cover, rainfall, which is not here. And for this, we can produce some hazard map related to each factor, and then we combine the factor to have the total hazard map where we have a problem of erosion. And this is another simulation. If you remove all the vegetation in the area, what will happen? So this is again the area of higher risk. Another M is management. Here, I will not show you the spatial result, but with this non-spatial database, we can connect with a spatial database, and any update that is done in the non-spatial database will reflect it directly in the spatial database. We'll see this in the course, how to do this connection of database to spatial data. The last M is manipulation. In this example, we assess the accessibility of people to health facility. We can see who are the people that are in 5 kilometers, 10 kilometers, 20 kilometers, 30 kilometers, or more than 30 kilometers to nearest health facility. Not only to assess that, but to see if there is a road to go to that health facility. In the next section, we'll see the type and model of spatial data. Come with me.